Okay, hi guys. This video is on something called quadratic inequalities, and we have been working a lot in class on inequality graphing, but it's all been with lines, it's all been linear inequalities. So let's talk about what a quadratic would look like and how would we do that. So the kind of problem I'm talking about, and I'm just going to write example 1 here, is you have an inequality that's something like y is greater than x squared minus 4. And when I see this problem, y is greater than x squared minus 4, I know right away in my head that, oh, it's x squared, it's quadratic. Usually a quadratic function, here's the bell. Usually a quadratic function distributes a curve that looks like a U-shaped graph, either pointing up or pointing down. So I'm pretty capable of graphing that, but the inequality, the symbol that's right here, the greater than symbol tells me that it's going to be one of those graphs where I need to shade. So this is kind of twofold. One, I have to know how to graph a quadratic. Two, I need to know how to shade points and figure out the shaded region. And we should at this point be able to do both of those things. So since it's quadratic, I'm going to figure out what's the vertex of the parabola. I'm going to find the vertex, and I'm also going to find where the roots of the parabola are, or these are also called the x-intercepts. So I'm going to figure out where's the vertex, where's the roots, and where's the y-intercept. And I'm going to do this pretty quickly here since this is kind of review for us. So vertex, we use a formula, x equals negative b over 2a. And in this problem, a is the coefficient in front of the x squared, so a is equal to 1. B is equal to the coefficient in front of x, well, b is 0 in this problem. And c is going to be minus 4. Those are my ABCs in my formula. So negative b over 2a is going to be negative 0 over 2 times 1, which 0 divided by anything is 0. So my vertex is at 0 and something else. And to figure out the something else, to figure out the y value, I'm going to plug 0, substitute 0 into this equation and make it 0 squared minus 4, which I can do pretty quickly in my head is a negative 4. So my vertex is at 0 and negative 4. Awesome, that is going to be either the lowest or highest point on my graph. So I'm going to go to 0, I'm going to go down to negative 4 and plot a point there. All right, now let's do the roots. Well, to find the roots, typically we factor. In this case, I'll do my work down here. I have x squared minus 4 equals 0. So I could do my whole rectangle diamond method, which would be totally fine, or I could look at this and say, oh, it's one of those shortcut ones where I can just add the 4 over. It's not so complicated. X squared equals 4, and I can square root both sides. Square root x squared, square root 4, which means x is going to equal 2 or negative 2. So it could be a positive or a negative 2, plus or minus 2, which helps me figure out my roots. All right, my x-intercepts are at positive 2 and negative 2. I'm going to write that up here. Plus or minus 2 are my roots, which means on the graph here at 2 is a root and at negative 2 is a root, which for me is pretty much enough information for me to draw my graph. The y-intercept, well, that's easy. If I put 0 in here for x squared, it's a minus 4. And I kind of already see the y-intercept because we had already placed it on our graph earlier. It happens to be our vertex. So I'm going to connect this parabola. Now, typically out of habit, I just start kind of connecting the plotted points and making this smooth curve. But hang on a sec, it's an inequality. So I have to determine, do I connect it with a solid curve or a dotted curve? And in this case, there's no equal sign. So it's all going to be dotted. I'm going to dot this. I'll be dotting all of my points. So nothing is solid here. And I know my parabola is going to look something like this. And there it is. And now I just got to figure out, well, where am I going to shade? And usually we shade like on the top of a line or the bottom of the line. We figure out, is it top or bottom? In a parabola, it's whether or not should we shade inside the parabola in here, or should we be shading on the outside part of the parabola? So test a point, just like we do with lines. Again, easiest point to always test is 0, 0. It's the simplest one. So I'm going to run a quick test on 0, 0, and I'm just going to do that down here. I'm going to write test 0, 0. And 0, 0 is going to be a fast test because the equation is y is greater than x squared minus 4. So if I put in 0, 0 is greater than 0 squared minus 4. 0 is greater than minus 4. And that is true. 0 is greater than negative 4. This one passes. Awesome. And if 0, 0 passes, this is what it means on the graph. Going back to my graph now. If 0, 0 does pass, then I can fill it in and say it's a solid point. And that means every other point that I test inside of here will also pass. And if you don't believe me, circle some other random point inside the parabola, wherever you feel like, and go test it in the equation, and it will be true. It should make it true, which means I'm going to shade all of the points, all of the region inside of my problem. Now, if 0, 0 had failed the test, I would be shading around the outside, but it didn't. It didn't fail. It passed. So there's my answer. And I'm going to write next to this graph that this is y is greater than x squared minus 4. And I'm done. And I have a lot of work to back up my graph. And that's kind of an easy version of these, so I want to do one more in this video just to make sure you kind of see where I'm coming from. So we're going to do the next one here, and we'll call it example 2. And for the next one, let's make the inequality just a little bit harder. So this time we're going to do y is less than or equal to x squared minus 4x minus 5. And I would encourage you to pause the video and see if you can do this yourself. And then turn the video back on and see if you got it right. All right, so I'm going to start doing all my work to find my vertex, my roots, and my y-intercept. Let's start with the roots, actually. I'm going to factor this thing. I want to know, when does x squared minus 4x minus 5 equal 0? When does that happen? So I'm going to break this into 2 parentheses and set it equal to 0. And you can solve this a number of ways. One simple way is our rectangle process, where we put x squared and minus 5 across from each other and make a quick diamond here. Negative 5 times x squared is negative 5x squared. Minus 4x goes in the bottom of my diamond. And I'm thinking 5 times 1. 5 times 1x is 5. And if I used a negative 5 times 1, that would give me a negative 4. Because negative 5 plus 1 is negative 4. So I'll put those in my corners. I'm going pretty fast through this because we've done this so much in class. So x times x is x squared. X times negative 5 is negative 5x. And negative 5 times 1 is negative 5. So here we go. X minus 5, x plus 1. X minus 5, x plus 1. Which means when I'm solving for my roots and I set each of these equal to 0, either x minus 5 has to equal 0 or x plus 1 has to equal 0. And I'm going to have 2 answers. X is equal to 5. That's a root. And x is equal to negative 1. Subtract the 1 over. So on my graph, at negative 1 here, I have a root. And at 5 way out here, I have a root. All right, what about the y-intercept? These are the x-intercepts. Let's talk y-intercepts here. Y-intercept's kind of fast. You can pretty much do it in your head. You're going to put 0 in for the x's. So y equals 0 squared minus 4 times 0 minus 5. So y is going to equal negative 5, meaning that my y-intercept is down here at negative 5. So I have that one that I can look at. Okay, so I have 3 pretty good points on the graph. Now I just need the vertex. So let's do that last step here and find the vertex. And for the vertex, we're going to use a formula. We're going to use x equals negative b over 2a. In this problem, b is a minus 4, so it's negative b over 2 times a. b is this thing right here. It's a minus 4. So negative 4 goes in here. A is going to be 1. So I have negative negative is a positive 4 over 2, which is 2. All right, so x equals 2 is where my vertex is at. What about my y value for my vertex? Where's that at? Well, y equals x squared minus 4x minus 5 is the equation, so I'm going to put 2 in there. 2 squared minus 4 times 2 minus 5 equals y. And that means y is going to equal 2 squared is 4 minus 8 minus 5. Quick math here, 4 minus 8 is negative 4, minus 5 is going to be a negative 9. Y is equal to negative 9. Okay, negative 9. So my vertex is at 2, negative 9. Okay, so let's go back up to the graph, add that to it. Oof, there's a lot of work to this. All right, here's 2. Negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. And I'm happy with this. I can make a parabola out of these 4 different points. I can see what direction it's going. Be careful to pay attention to the symbol. There is an equal sign down on the bottom here. So I do know that it's going to be a solid parabola, no dotted parabola, which helps. I'll connect my points here. And really it comes down to shading. Am I going to shade inside the parabola or outside the parabola? So test something inside or test something outside. Test anything you want, really. I always test 0, 0. It's easy. If I put 0 in here, think about it. It would be 0 is less than or equal to 0 squared minus 4 times 0 minus 5. So all of this is going to be minus 5. 0 is less than or equal to minus 5, a negative 5, and 0 is not less than negative 5. That actually fails the test, which means I'm going to put a little x in there. I'm not going to be shading where that is. I'm not going to be shading inside the parabola at all, not where that point is. I'm going to be shading on the outside of the parabola. All the values on the outside will pass if I test them. And that graph is my answer. All right, so I hope you kind of got the hang of this. They're all kind of the same, similar process. There's a lot of work to them, but they're kind of fun to do. All right, bye.